In the previous video we looked at drawing streamlines of vector flow. In this video we're going to go through in depth with the use of color maps in data visualization. Color maps in general can be categorized as this. Sequential, monochromatic color maps of two color tones from low to high saturation of the same color. For example, from white to bright blue. Ideal for most cases as they clearly show the change from low to high values. Diverging. The central point here is the median value, but then ranges go from there to two different color tones in a direction for high and low values. This can be ideal for data with significant median value. For example, when the median is at 0, it clearly shows the difference between. Qualitative. For cases where the data has no inherent ordering and all you want to do is make sure different categories are easily discernible from each other. Cyclic. It's used when data can wrap around endpoint values, such as representing time of day, wind direction, phase angle, or similar. Matplotlib comes with a lot of predefined maps and are able to divide them into several categories. We will suggest when to use some of these color maps. The most common and base color maps are autumn, bone, cool, copper, flag, grey, hot, HSV, jet, pink, prism, sprint, summer, winter, and spectral. We have another set of color maps coming from the Yorick Scientific Visualization package. This is evolution from GIST package, so all color maps in this collection have a gist underscore as the prefix in their name. The Yorick is a visualization package and also an interpreted language, written C, not quite active lately. You can find more information on this official website. Now we can set the color map on many items in Matplotlib. For example, color map can be set on image, p-color, and scatter. This is accompanied usually via argument to the function called cmap. This argument is an expected instance of colors.colormap. We can also use matplotlib.pyplot.set_cmap to set cmap for latest object plotted on the axis. You can get all the available color maps easily with matplotlib.pyplot.colormaps. Fire up IPython and type in this code. This will import the pyplot function interface and allows us to call the colormaps function, which returns a list of all the registered color maps. Finally, we want to show you how to make a nice looking color map. In this example, we use the Color Brewer website to get divergent color map colors in the hex format. Next, generate a random sample of x and y, where y is the cumulative sum of value, simulate stock price variations. Then apply customization to scatterplot functions of matplotlib. After this, tweak scatter marker line color and width to make the plot more readable and pleasant for viewers. This will render a nice looking figure. Here we are on the Color Brewer website to find out colors in red, yellow and green divergent color map from ColorBrew. Then we listed those colors in our code and applied them to our scatter plot. Using matplotlib.plyplot.register_cmap, we can register a new color map to matplotlib, so it can be found using the getCmap function. We can use it in two different ways. Here are both signatures. Register CMAP, name equals swirly. CMAP equals swirly, CMAP. Register underscore, CMAP, name equals choppy. Data equals choppy data, LUT equals 128. The first signature allows us to specify color map as an instance of colors.colormap and register it via the name argument. The name argument can be omitted, in which case it will be inherited from the name attribute of the CMAP instance provided. The latter one, we are passing 3 arguments to the linear segmented color map constructor and registering that color map afterwards. Using matplotlib.pyplot.getCmap, we get the colors.colormap instance using the name argument. Here's how to make your own map using matplotlib.colors.linear segmented color map. This is the simplest part, while the hardest part is to actually come away with a combination of colors that are informative, do not take away from the data we want to visualize, and that are pleasant for the eyes of the viewer. For the base map list, we can use the Pylab shortcut to set color map. For example, the following code would set the color map of the image X to... Great! In this video we saw how to use color maps to enhance our data visualization. In the next video we'll see the use of scatter plots and histograms.